Okay, good evening. This is Professor David J. De Los Reyes. April 1, 2023. The time is 11:11. It's almost 12 a.m. Okay, April 1, 2023. This is Professor David J. De Los Reyes. Okay, my topic for tonight will be a continuation of our advanced mathematics on the topic Laplace transform. Okay, what I will be discussing tonight will be the Laplace transform formulas for solving circuitry that involves alternating current. So we are now through with the formulas for Laplace transform for direct current. So for tonight, I will be deriving the Laplace transform formulas needed in the computation or circuit analysis of alternating current circuit. Okay, let's proceed. My topic for tonight will be advanced mathematics. This is now advanced math lesson number 26. And I will be deriving one of the formulas needed in the so-called analysis of alternating current circuits. That is the Laplace transform of the formula sine of the open quantity omega t plus angle p. I will underline this equation here because in the analysis of alternating current circuits, okay, it involves the so-called sine function and cosine function. So I will try to bring out the Laplace transform of sine of omega t plus angle p. Because without knowing this one, okay, we cannot bring out the so-called solution using Laplace transform if we proceed with the circuit analysis of alternating current circuit. Okay, let's proceed. The derivation is something like this. What will be the Laplace transform? The given equation is sine of open quantity omega t plus angle p closed quantity equal to. The formula for taking the Laplace, it should be the integral from 0 to infinity of the given function. The given function is sine of the quantity omega t plus angle p, it is this. Okay? Times e raised to minus st. We are transforming that function of t to a function of s. So this is multiplied by e raised to minus st times differential time. Okay? That's the standard formula for taking the Laplace transform of any function. Okay? Any function. So if we try to continue with the solution, this should be equal to the integral from 0 to infinity. To integrate this one, we must have to bring out the expansion. And the expansion of this, I will read it before I will explain where it came from, okay? It will be open bracket sine of omega t cosine of angle p plus cosine of omega t sine of angle p close bracket. Okay? I brought out this one because if we try to expand sine of the quantity omega t plus angle p, the expansion is actually sine of omega t cosine of angle p plus cosine of omega t sine of angle p. First angle, second angle, first angle, second angle. It should be sine, cosine, cosine, sine. If this is plus, this should be plus. And where did that equation came from? It came from this. Under the study of trigonometry, that's why I told you before, one of the requirements or prerequisite of advanced mathematics is our knowledge of trigonometry. That is, the expansion of sine of the quantity a plus b, close quantity, equal to, try to recall your sine of a double angle in trigonometry. It will be sine, cosine, cosine, sine, first angle, second angle, first angle, second angle. If this is plus, this should be plus. Okay? This formula here emanates from here. Because we try to substitute angle A to be omega t and angle B to be angle V. Okay? So replace A and B by this value here. What will come out will be sine of A plus B will be omega t plus angle P. And following this, sine of A A is omega t, cosine of B, but B is angle P, plus cosine of omega t, sine of angle P. So this formula here is what we need to take the integral of the right hand side. Okay? Meaning the expansion of this will be sine of omega t cosine of angle P plus cosine of omega t sine of angle P. It emanates from that one, our knowledge of trigonometry. Okay, guys? I will check my camera. Okay, yeah, you got it. Okay? So after taking the expansion by using the double angle, using our knowledge of trigonometry, we try to expand, okay? So this first part here, times e raised to minus st dt, it will be this one. Right? It is this. We just expand. And the second part, this is plus, right? So this is plus. Cosine of omega t, sine of angle P times e raised to minus st dt. It is the second part. So this is plus the integral from 0 to infinity of cosine of omega t, sine of angle P times e raised to minus st times dt. Okay, we just expand. So that's so-called algebraic manipulation. That's why one of the prerequisites is that you must know how to algebraically manipulate. Okay? So, proceeding with the integration now, we got two integrations, right? Okay, for the meantime, before we will proceed with integration, take note that angle P, cosine of angle P is constant, and sine of angle P is constant. So if we try to take the integral of the first one, this cosine of angle P, treat it as a constant. Angle P is not expressed as a function of time, right? So if you take the cosine of any angle, okay, it will be constant. So we could bring it out from the integral sign. So this will now be, that's the reason why we bring it out. It is a constant. Cosine of angle P, the integral from 0 to infinity, what remains inside the integral is just the sine of omega t, a raised to minus st dt. So it's a pure function of t and dt. The first one is sine function and the second one is exponential. Okay, plus the integral of this. Since sine of angle P is constant, right? It could be any angle. If you take the cosine, it will be a pure constant. And if it will be a pure constant, we could bring it out of the integral sign. So this is sine of angle P, is plus, the integral from 0 to infinity. What remains inside will just be simply cosine of omega t, e raised to minus st dt. Okay, so you now know the reason why this cosine and sine came out from the integral sign. Okay, for proceeding with the solution, I will place it here. Okay, but I place it here. The integral from 0 to infinity of sine of omega t, e raised to minus st dt. Actually, we are done with that. I think it's either formula number 5 or number 6 under the Laplace transform formula. And the integral from 0 to infinity of this, okay, it is one of the Laplace transform formulas. It is this. It is omega. For a sine, this should be omega, numerator. The denominator will be s squared plus omega squared. Okay? And the integral from 0 to infinity of cosine. The first one is sine. Cosine of omega t, e raised to minus st dt. Actually, we are through with that also. It is one of the formulas. I think it's number 6 or number 5. And the equivalent of the integral from 0 to infinity of this is actually s over s squared plus omega squared. For a sine, the numerator will be omega. For a cosine, it is s. So you now know the importance of the first formulas, because without knowing the first formulas, we could not proceed with this. That's why I'm telling you, there's a sequence on how we learn, okay? We do the basic thing, because the basic thing, we need that in the more complicated formulas. That's why I brought out that the integral from 0 to infinity of this is actually omega over s squared plus omega squared. I have derived that one already. The integral of this will be s over s squared plus omega squared. Because without knowing this, there will be a problem. Because before we could take the integral of this, we will derive this. But the mere fact is, we have done this already, so we will just bring it out. Okay? So replace this value here by omega over s squared plus omega squared, and this value by s over s squared plus omega squared. Going back to this, okay, I will rewrite cosine of angle P. Is this. The integral from 0 to infinity of this is actually omega over s squared plus omega squared plus sine of angle P times the integral of this, which is s over s squared plus omega squared, close bracket. So actually, we simplified the derivation, okay, because we now know the equivalent of the first one and the second one, because we have done that from the previous lessons. Okay, so simplifying, this should be equal to s sine of angle P plus omega cosine of angle P. I just write this one first, okay? Okay, s sine of angle P is s sine of angle P, okay? Omega cosine of angle P will be omega times cosine of angle P. Their denominators are the same, so it is under one single denominator, addition of fractions. Their denominators are the same, so we will just rewrite the numerators under one denominator. That is algebra, okay? So this is s sine of angle P plus omega cosine of angle P all over s squared plus omega squared, the common denominator. Okay? So the final formula on how to take the Laplace transform of sine of omega t plus angle P should be equal to s sine of angle P plus omega cosine of angle P all over s squared plus omega squared. Memorize this by heart, because when we go with the solution of alternating current circuit, it's a must that we should know the Laplace transform of sine of omega t plus angle P. So when we take the so-called inverse Laplace of this, we could say that inverse Laplace of this will be sine of the quantity omega t plus angle P. Okay, it's the reverse thing. But it's a must that we should know that the Laplace of sine of omega t plus angle P is sine of angle P plus omega cosine of angle P all over s squared plus omega squared. Okay? Oh, that's it, guys. That's one of the formulas for taking the Laplace transform when we go to the solution of alternating current circuits as a function of time. I will check my camera again. Oh, that's it. So it's going more interesting, right? Because we brought out already one of the formulas in the so-called Laplace transform solution of alternating current circuit. You notice that under the alternating current circuit, it involves the sine function of omega t plus angle P. Actually, our next lesson will be the inverse Laplace of cosine of omega t plus angle P. So, by knowing the last two formulas, we can now proceed with the solution of RLAC, RCAC, and RLCAC. We will be solving those problems by using Laplace transform formulas without using the so-called classical solution differential equation. Okay, so for those persons who are taking advanced mathematics, this is for you guys, okay? If you want to subscribe to my channel is at youtube.com/@proofdavidj.Reyes. And if you want to share it, please click share. Good evening from Los Angeles. Okay, I will repeat it for the last time. The Laplace transform of sine of the quantity omega t plus angle P is sine of angle P plus omega cosine of angle P all over S square plus omega square. Good evening from Los Angeles.